Hi, I'm Phil, and today we're going to look at the Keyestudio Motor Drive. So we'll use this mind map to navigate and have a look at the device. And what it is, it's a breakout board for microbit that drives and controls Lego Technics power function motors, like the M motor. And we're going to demonstrate the four modes of the motor. We'll make the motor go forward, reverse, brake, and stop. And you can use a external power supply for the motor, but internally the board operates with either 3.3 volts or 5 volts. And it's all based on a chip from Toshiba. So it's a H drive for two motors. And if you can work out the truth table for this, you can then begin to develop your own program. So you can see that the motor itself will support continuously about just under 1.2 amps on a single channel, and you have to reduce that if you're using it on a more regular basis. So you can see a typical application for it here, and we're going to use it with Lego motors, and they typically have a 9-volt power supply. So you can see the board, and we'll have a look at the software. We're going to use MakeCode. The demonstration arrangement is this one: turns the motors on for 3 seconds, then just reverses them. And here is the code. So you can see that it's all fairly straightforward, and there's no special extensions for MakeCode needed. But you do have to turn off the LED, the microbits onboard LED. And here are some of the projects that I'm working on and planning for the future. So I've commissioned it, and I've added some extra support for the board itself. But in the future, I'm looking at some environmental entertainment projects with a merry-go-round and Ferris wheel. And all these projects, they all require electric motors, and they're just models. So these are some of the projects that I'm working on. I haven't started those other ones, but the commissioning projects, well, let's just go through and just see what the project is all about. So you can see what it looks like on my desktop. On the left here, I've got two M Lego motors, and they're connected to the terminals on the Keyestudio Motor Drive board. So the objective for testing it is to run the motors in all modes, which means forward, reverse, brake, and stop, and interface that with the Lego power functions, both the power supply, and to develop a wiring harness that allows me just to connect to the power functions power supply and M motors. And I'm also going to develop some mechanical support for the board itself. Now, for the design, press button A for forward, reverse, press the logo button, and it will stop it. And we'll have a look at the code in a minute, but quite simple. This is my code, and you can see that I initialize it, and I've set up the buttons for forward, reverse, and stop, and I'm using functions to control the mode of the motors. And just before we have a look at the software, let's have a look at the hardware. So one nice thing about the Lego motors is that there's been a lot of study about their technical performance. So besides using microbit and the Keyestudio, I've got some bricks, a base plate, and power functions. I've got the battery box, and you can see the connections for the battery box. It comes with a wiring harness, and I'm cutting that to access the outside wires for power, and the inside wires are used for controlling the motor. So there's some of the characteristics of the motor. And I'm using standoffs. So the connection for that, when I'm doing the power wiring, you can see how I'm putting that together. I'm cutting the harness, and I'm establishing what the polarity is. And I then do a bit of soldering and do some drilling on a perspex plate to support the board. And these are the standoffs that I'm using. And here's the wiring diagram. So you can see microbit is sitting on top of the Keyestudio Motor Drive Board. And here are the connections for one motor. And the color coding shows how the inside and outside connections to the power functions wiring cable, how it works. And I got all the results. Everything worked quite well. And let's just have a look at the pros and the cons of that board. Let's move it out. So in review, it worked. And with the examples, it's fairly straightforward with no complicated hidden extensions for make code. The only thing is that there's not a support base for the motor drive board. And other than that is good performance. So if you're interested in getting that, have a look at the Keyestudio website. It has a wiki that will show you how to do your programming. And here are some of the other contacts. If you want an alternative board, the Elecfreaks, the support mounts are Lego Technics compatible. So you can actually, you don't need to add an additional acrylic plastic plate for the to support the board, and you don't need the standoffs. And that's it for the time being. This is the Keyestudio KS4033 Motor Driver Board, and it's hosting a microbit computer. So we've got the microbit computer on the right and the motor driver board on the left. And it's connected to Lego M motors, the two of them. So if you can see the terminals, we've got power, motor 1 and motor 2, and we're ready to give it a demonstration. So this is for Lego Technics power function, power supplies and motors, and the only requirement is to cut the normal cable that you get with the these kits and add the wiring to the motor driver board. So let's have a look and see what it does. So when I press button A, we're going to demonstrate the forward motion. If I press button B on the microbit, we'll see the reverse direction. And if I press the logo button, we'll stop it. And that's the Keyestudio Motor Driver Board with microbit.